Okay. ஒரு fine.
Shall we start, sir?
Okay, Anchal. Right, anyhow, let the people join. Yes.
I am ready, sir.
Okay.
Okay, we can
Okay, I will start. I will give the welcome speech.
Yes, yes.
Good evening, participants. IEEE CS Madras, ACM Chennai, and CSI Chennai chapters cordially invite you to a webinar on data science, trends and opportunities by Mr. Karthikeyan Sankaran, Director, LatentView Analytics. Nowadays, data science is heavily used or abused. Data science is a field that uses an interdisciplinary approach to make sense of the data and extract actionable insights. Data science is a fascinating domain that is growing exponentially with the growth in digital transformation across industries. In this webinar, Mr. Karthikeyan will explore trends and related opportunities with specific focus on broad framework to think about data science and artificial intelligence in business context, current and anticipated future trends in the world of data science in helping overcome its limitations and embrace new opportunities. Opportunities provided by data science to students and professionals to solve a variety of complex and interesting problems. In conclusion, this webinar hopes to drive home the point that data science is a fundamental skill to be acquired, has immense power to solve problems, but needs to be utilized in a responsible manner. Mr. Karthikeyan Sankaran, known as Karthik, has worked in the software industry for close to 23 years with expertise in data management and advanced analytics. Currently at LatentView Analytics as business head for financial services, insurance and consumer verticals, his focus is on applying data science to solve real-world problems in a simple and effective manner. He is associated with Great Learning, Upgrade, Praxis, Analytics, Vidya in training and mentoring professionals in the field of AI and ML. Mr. Karthik has completed his BTech and MTech at IIT Madras and MBA from IIM Calcutta. He is a life member of Computer Society of India. Over to Mr. Karthikeyan. Thank you.
Okay. Am I audible, sir? I hope I'm audible.
Yes, sir.
Yes, you're audible.
Okay, thank you. Thank you very much. Thank you very much for the introduction. It's a real privilege to be here and talking to all of you today. Good evening. Hope everyone is safe and healthy. Please take care, be safe. So what I'm going to do over the next 1 hour is to give you a flavor of data science. Data science is a very broad area. It has a lot of, as previous just mentioned, it's a very interdisciplinary kind of space. So what I will try and do is to provide you a flavor of what data science is about, relate it a little bit to how we think about data science in the context of artificial intelligence, machine learning. I will just touch upon the topic. and talk about some of the trends and why this is a great time to learn some of these skills. I think it's one, it's very interesting, and two, it could make for a very rewarding career, whatever stage of your career you are in, right? So that's really my focus for this presentation. And I will go through this presentation and then I will take questions towards the end of the presentation, right? So with that, I'll get started. Again, thank you once again for inviting me and for spending your valuable time with me today. Okay, so just start off. All of you would have seen slides like this, right? This is just one such slide, which basically tells you the amount of data that is getting created in the world at this point in time, right? And again, as I said, this is a standard slide in many places now, at least either the same one or similar slides like this, which talks about the amount of information. For example, 500 million tweets are sent out every day, right? 4 terabytes of data produced by a connected car, 2294 billion emails are being sent, right? All these different types of data points. And look at this, this is very interesting, right? So 2013, overall digital data was around 4.4 zettabytes, right? 1 zettabyte is, it's in the order of so many zeros of bytes, right? Right now, at 2020, we are at 44 zettabytes, which means there is a 10 times increase over the last 6 to 7 years. And this is expected to go up significantly over the next 5 to 10 years, right? So bottom line is everything is generating a lot of data, be it transactions, right? The kind of transactions that we do in whichever space that we are in, banking transactions, right? E-commerce, retail transactions. Then there is the other piece of data, which is all your social media content called as interactions, right? People interact with one another in so many different ways, right? So that generates a lot of information. And the other piece that's generating a lot of data is all your sensors, right? So all the sensors that are out there is also generating a whole lot of data, right? So that's a starting point for all of us to say the raw material is there. So now the question is, what do you do with this? Right? So just because data is there, it doesn't mean you can actually use it, right, appropriately. And in fact, it becomes a little more tougher to look at it when you have a data present in Excel sheet. You can handle it in a certain way, but what about streaming data which is coming in at such a velocity? There is just so much of data that's kind of coming in. How will you handle it, right? So what is the point of all this, right? So with this as a starting point, let's now shift focus a little bit, because we are not talking data science, correct? And so you've seen the data part of it. Let's look at science and then start connecting the two, right? So before we go to data science, let's just understand the goal of science in general. I know many of you are professors and people from the academic world, right, who are well versed in aspects of science and technology and different areas like that. But the bottom line, if you look at the goal of science, right, I'll just give two simple examples. This is Ernest Rutherford. I think many of you would probably know him as the person who discovered the structure of the atom, right? And so this is a famous Rutherford's experiment called the gold foil experiment, right? Conducted around about 1908 to 1913 kind of a time frame. It's a series of experiments. And what finally, so there was some notion of what an atom was before this. And then based on this experiment, we came to the conclusion that atom has a central nucleus and then it has electrons surrounding it. So essentially, this experiment was able to help us figure out the structure of the atom, right, from whatever information we had prior to that, right? So this was just an example. And the other example I have is the Mendeleev periodic table, right? When Mendeleev was, there is a lot of elements that were out there, but they had no structure to it, right? So around about the 1860s, 70s kind of a time period, Mendeleev came up with a concept of a periodic table, and there was a notion of how to organize these elements in a certain way, right, based on these atomic numbers. And many of us would have studied all this in our school and college days. But the beauty of organizing this data was that Mendeleev was able to predict what elements could come in the future, right? Even though those elements were never discovered at that point in time, right? So he was able to basically structure the data that he had in a certain way, right? Because of which he was able to predict what is going to come down the line, right? So, and there are multiple examples like this. You take a Edison, you take a Tesla, you take a Einstein, right? Everything is based on a series of experiments. But bottom line is the goal of science, if you take it in a very simple way, is to take information that you already know and create information that you don't know, right? Or you don't have. That's the essence of science. Take whichever discipline it is, you basically have some information, which is again over a period of time people know about it, right? Then you use that and then create information that you don't know or you don't have at that point in time. Agree? So this is the essence of science. So what is data science, right? Data science essentially does the same thing, right? It takes information that you have, which we call as data, right? And it creates information that you don't have, which is what you call as predictions, insights or predictions. I will give you some examples in the subsequent slides, but this is the essence of this presentation, right? Now, how we do this, what are the complexities in terms of making this conversion, what is the right way to do it, how do you test that your predictions are right in the business context, etc., are all details, right? But the goal of data science at any point in time is to say, I have certain data, which is the information that I see that I have, and I'm trying to use that data to create information that I don't have currently. Okay. And that is what data science is. Okay. Data science accomplishes this task, this conversion, in the context of solving business problems. Typically, when you say data science, there is a business angle to the whole thing, right? I'm saying majority of the cases, there could be certain research aspects and probably not business kind of situations, but more often than not at this point in time, the bulk of data science work that is being done right now, it is all related to some kind of a business problem or the other. What price should I set for my product? What will be the demand for this product 3 months down the line? Will this customer leave my, get out of my product or a service, right? Things like that, right? We will talk about that a lot more, but it accomplishes this task of conversion in the context of business problems using mathematical techniques. And this is kind of unique to this space. So it's not that the mathematical techniques did not exist before, but there was no way to bring these techniques, the power of some of these techniques, the statistics, the statistical modeling, the machine learning, and some of the advanced AI kind of techniques in the context of business problems. There was no way to do that before. And now you have the ability to do that with the advent of data science, right? And the other key thing is by using data as the raw material. You could solve business problems in many other different ways. For example, you can create simulation models, right, by which you can solve the problems, or you can just go by your gut feel, your intuition in terms of solving problems. All that is fine. But what makes data science different is the fact that you use data as a raw material. You bring in the power of these mathematical techniques, right, in the context of solving business problems, right? So this is what data science is. A fairly simple slide, but I thought I will do a level set to say, this is what is data science, and we will start describing some aspects of this as we move forward in subsequent slides. Okay. Now, just to reinforce that concept, let me have a few examples, right? Of course, this is all in a business context, right? So in the case of an online banking kind of a situation, right? What is the data that the company has or the bank has? They basically have customer attributes, right? Who is the person coming in, age, gender, etc., right? Product details, which product is this person he or she is accessing, right? Savings account, loans, etc. And then you have the transaction history, the kind of fund transfers you might have done, deposits you might have made, etc. So this is the information that the bank actually has, okay, and that is data. One of the things that they will not have is something like this: whether a particular customer will leave the bank or not in the next 1 or 2 months. Correct? And that is something which is created based on this data, and this is done through data science. Okay, using all this data, if you can create or get an answer to this question, so just using some mathematical techniques, right? This is what is called as a classification problem, right? Forget about the techniques per se, but if you're able to convert this, what will it say? It will say, oh, this customer C1 will probably leave the bank in the next 1 month with a probability of 95%, right? The other customer will not leave the bank, or the probability of the customer leaving the bank is less than 1%, right? So it will give you that kind of a probability based on which you can take some action. If you see a very valuable customer, the probability of the customer leaving the bank is 95%. What will you do? You will try and retain that customer, right? By giving offers, by giving some certain other freebies and things like that. But this information needs to be created and that is done through data science. Okay. Another example of a retail store. What is the data that a retail store has? It has the product sales across different time, right? Different quarters, months, weeks, etc. It has the location of all the different stores by which it sells the product. So it has all this information, right? What it will not have, which has to be created, is what will be the demand for the product or a particular set of products or a particular product in the next 3 months in each of the stores, right? That is not something that they will have unless you employ or deploy data science to convert this data into creating this demand or forecasting the demand for products over the next 3 months, right? And this conversion is accomplished by using data science. Now you can imagine, if I know this and if I know this accurately well, it is very useful for me when I run my store, right? Then I will know what products to bring into that store, have in that store, so that customers are not disappointed. Or the other way around, I need not bring in products and have a lot of inventory of the product if that's not going to sell, right? So I can make my supply chain very efficient if I have the proper forecast. And if I'm able to use data science to predict this accurately, then I can run my business much better, right? And just to give an example of a situation where it's not about the future, but it's about the present, right? So again, Google Assistant, Siri, etc. What do? You utter something on the phone. Okay, a customer utters something, asking the phone to take some action. Now, what is the prediction here? All of us speak in very different ways, right? Different accents, different ways of pronouncing a word, etc. But the algorithm that is there within the assistant or Siri has to precisely identify what the customer has uttered so that appropriate action could be performed, right? This is also data science, right? In the sense that there is an aspect of machine learning which will help you to understand what exactly has been uttered. And so once you do that precisely, then you can take the appropriate action, right? And this is prediction in the present, not in the future, because I need to get it right now in order to perform the action. Okay, I can give again many such examples, but hopefully it's clear, right, that based on the data that you have, if you are creating information that you don't have, and of course, it's important that you create information that's useful for you, right? When you're as aspect of the business, what's the point in just predicting something which is not useful? But if you're able to predict something that is useful, then I can organize my business and my operations in a better manner so that I can be efficient about doing the same thing. This is the essence of data science again. Again, the previous slide, this is just a set of examples to illustrate the fact that this conversion is what is done by data science. And why are we studying data science in a big way? Why is there such a big body of knowledge? Because this conversion is not easy. In some cases, it might be very simple, but in many cases for very complex problems, in order to precisely get this conversion and really test whether this conversion has happened correctly is a reasonably complex we need to think through that process, right? And that is why data science is there is such a body of knowledge which is relevant for data science. Okay, we'll probably come back to this if required. So how does this magic happen? Just to give a quick view of it. So as I said, I'll keep talking about this all the time, right? Take information that you have data and create information that you don't have, which is predictions, is what data science is all about. So if you keep that as your basis, the magic happens by essentially you need to use two things. One, you need to have the ability to acquire and extract all this data, because the data is residing in multiple different places, right? It could be in a database, it could be in a sensor, it could be in a social media platform, it could be on a website. So there should be ways by which you should be able to extract the data, right, in the appropriate way. And then of course you need to analyze the data, analyze and do all sorts of things on top of the data in order to create the information that you don't have. So these are the two big blocks that anybody has to do when it comes to activities surrounding data science, right? And if you look at it in terms of extract data, an example or the one that is used heavily in the industry is SQL, right? You need to have SQL knowledge in order to extract data, mainly structured data that is present in databases, which is how most of the business data is, right? But at the same time, there are a lot of other ways also. What about if you have to get data from a website? you cannot issue a SQL query, right? Similarly, if you are getting data from a sensor, you cannot use a SQL query, right? So there are many other ways of also extracting data, but SQL is the predominant way because most of the business data, which is a starting point for you to do data science, is all present in databases, in ERP systems and CRM systems, etc. So you need to have good, strong SQL skills if you're a data analyst. As a data analyst, the first important piece is to really extract the data so that you could use it for further analysis, right? When it comes to analyzing data, though we keep talking about machine learning, artificial intelligence, etc., right? We don't start there, right? Because there are many simpler ways to actually analyze data, and if that works, that is what we should use. Simpler the process, then you have a much better chance of actually implementing it in the real world. More complex it gets, it becomes all the more difficult. So that is something we have got to always remember. If a problem can be solved in a simpler manner, that is what we should go for, right? And not really look for complexity just for complexity's sake, right? So Excel is definitely a big way by which you can analyze the data. Then typically when the data gets large or there is a large volume of data that you need to analyze, in most of the cases, you basically do visualization. And visualization is nothing but, if you look at if you have worked with tools like Tableau, ClickView, Power BI, MicroStrategy, and things like that, these are tools, or D3, open source D3.js kind of things. Basically, this is a way by which you can, when you have tabular data, let's say, right, you can actually put it into charts and graphs and histograms and all that so that you get a better intuition for the data. So visualization is a very, very important aspect of data science, right? There's just so much of visualization that gets done in data science that we say in our company when we conduct those trainings and boot camps, this is something that everybody learns, irrespective of years of experience. The ability to take a data set and visualize it in multiple different ways using the power of some of these visualization tools is a very, very core skill, right? And that is when you know whether you have the right data, whether you have data of the right quality, right? And whether you can start using some of the sophisticated analysis on top of this data. So visualization is a key point when it comes to, or a key area when it comes to analyzing data. Then, of course, you get down to the next level, saying that statistical analysis. Again, I'm not going to get into the details of this. This probably warrants a separate discussion on into the depth of statistical analysis, machine learning, etc. And many of you would probably know quite a bit of this. But what statistical analysis basically tells you is, okay, what if I can't get to all the data, but I can take samples, right? So from a sample data, can I find something about the population? So for example, let's say I'm running a marketing campaign, right? And I send it to 100 people, and let's say 30 people actually subscribe for that, right? Now the question is, okay, so in the real world, when I actually send it to millions of customers, how many customers? Will I get a 30% hit rate as I got with 100 people, or will it be much lower? Right? So that is what basically a statistical analysis can tell you on how statistically significant a particular value or a particular parameter is, right? So that I can actually find out something about the overall population from the sample that I've taken. Okay, and this is used extensively in the industry. Again, I gave an example of any kind of a campaign, marketing campaign, you use statistical analysis to really understand from a sample, can I extrapolate to the population? Right? Then as you go further, you'll have to start focusing on, okay, I have lots and lots of data. Can I start doing predictions? And that is where machine learning kind of comes in. The difference between, in some sense, statistical analysis and machine learning is the focus of machine learning is on predictions, right? The focus of statistical analysis is to really understand something about the population. Okay, so the focus is different, but many of the techniques are actually same, or there is a very strong combination that you will use between statistics and machine learning in order to analyze the data and come up with different types of predictions. But just to emphasize the fact that when you're looking at statistical analysis, the focus is on looking at the sample, can I find out something interesting about the population? Machine learning, if you do that, great, but the focus of machine learning is, okay, given a bunch of data, can I predict something about the future? Like the example I showed you earlier, right? Where the retail shop has a lot of data on the historical sales from each of the stores, for each of the products. Then machine learning will help me to find out what will be the demand for a particular product 2 months later, or 2 months down the line, or 3 months down the line. What will be the demand next week, right? So those are the things that machine learning will help you to do, right? So analyzing data, these are some of the ways that you could do this. Of course, there are business stakeholders for whom this information has to go, right? Otherwise, what is the use of all these predictions? So there is a very, very important aspect of communication, because if you really look at it, the business stakeholders are not experts in data, right? They are experts in the process, they are experts in the business, right? And they are very good in terms of figuring out, okay, if I do this, what will happen? Cause and effect relationships, right? So the ability to really communicate all your analysis, right, and the predictions and insights that you're coming up with to the business stakeholders so that they can use it for their for better decision making, right, is the crux of data science. So communication is a very, very important aspect of data science itself. Okay, just moving on. Okay. Now that we have seen what data science is at a high level, this conversion from what I have, which is data, to what I don't know or what I don't have, which is a predictions, is what you try to do all the time, right? And why is it important for enterprises? Because every organizations take hundreds of decisions on an ongoing basis, right? Of course, I'm talking about, I'm just saying business, etc. But of course, I'm talking about every, for example, a university, right? Or a college takes so much, they have to take so many decisions on a daily basis. And larger the organization, larger or more the number of decisions that are to be taken. And if you really look at it, these are decisions which are very abstract. Should I acquire company A? Should I enter into another country, right? Should I sell my product in a different country, right? So these are some really broad questions that organization needs to answer. At the same time, you also have questions like this, right? Should I hire this person or not? Should I run one extra shift in the manufacturing plant today so that I can get more throughput, right? So there are a whole series of questions that every company has got to answer. Okay, and so decision making or business decision making is becoming more and more complex with the advent of digitization, globalization, and things like that. And each one of us are changing very profoundly also, right? So the 7 billion people who are in this world are also profoundly changing in terms of the way they buy, sell, interact with one another. Even the learning process is changing dramatically, right? So much of digital based learning and things like that. So the world is changing dramatically, and every business has hundreds of questions to answer, and that is becoming more complex. So what do? They say, okay, can data science provide me an answer? Because data science seems to be a field which will help me take the data. I have a lot of data, right? Of course, companies like Google, Facebook, Microsoft, which are digital companies, anyway have a lot of data. But even other organizations, right? Banking, financial services, insurance, airlines, manufacturing, everybody has tons of data that they have collected. And on the other side, they have decisions to take which are complex, which are getting more and more complex. And now they are saying, okay, can data science help? With this data, if I can actually get answers to certain questions, I can probably take better decisions for my company and for myself, right? So that's the reason why there is so much of interest in data science at this point in time. And this is again a simple slide to indicate the goal and purpose of data science. So this is the real world, right? Of course, I'm talking about a business world, but it is equally relevant for your own personal kind of thing also, right? So you have a real world out there, and nobody can understand the real world in entirety. It is just far too complex, too many interactions, too many variables, a lot of what is called as non-linear kind of relationships. It's impossible to understand the real world completely for anyone, right? But even in that context, if you see the business decision makers or decision makers in general, they have to take decisions. And how do they do that? They build some expertise about the real world, right? Which is in some sense an approximation of how the real world could possibly operate, right? That is what everybody builds in their minds, right? And even we do that in our own personal setting, right? So in saying that, okay, I think if I invest the time to learn this, then A will happen. And if A happens, B will possibly happen. And if B happens, that's very favorable for me. But if A does not happen, right, might not have probably a good job to work on, and so that is not a favorable situation for me. So we have all these approximations in our mind, and that is what we have built over a period of time based on feedback, based on experience, etc. Right, and you use that to take decisions back in the real world. Okay. And the decisions could be in terms of buying something, finding a college for yourself or for your son or a daughter. And there are so many decisions that we take on a daily basis. And think of it from a business context. A CEO of a company would be concerned with decisions like, as I said, right? Should I enter into this country? Should I acquire that other company? Right? Things like that. Whereas if you go to the next level of a tactical decision making, like a head of sales and marketing, he is concerned about questions like, what campaign should I run next week? What price should I set for my product? What kind of discount offer should I give? Right? And if you take a person at the operational level, right, for example, a floor plant manager, right, she is concerned with questions like, okay, how many shifts should I run today? And there seems to be bottlenecks in the process. How do I alleviate it so that I increase the throughput? How do I improve safety on the shop floor? Right? So there are many different questions that each one have got to answer. Now, the goal and purpose of data science is this, where every single process inside and outside of organizations, right, is generating a lot of data. So if you can actually take the data, apply the relevant mathematical techniques, right, it can be a simple Excel-based analysis to visualization, to statistical modeling, to machine learning, to advanced artificial intelligence techniques, right? If you can apply the right techniques on top of this data, and you come up with the relevant inferences and predictions, right? And if you can communicate this appropriately to the business decision makers, so that now they understand, oh, this is how really the world is happening in the real world, because the data is a depiction of reality. Whatever they might be understanding might not be the thing. For example, you might have a notion of what is the price for a product that will work in the market, which is based on your experience 5 years back, right? But then the reality might be different. Your competitors have changed. So there are so many different things that are happening, and data is a better depiction of reality. And so if you can use the data, come up with the inferences and predictions, and communicate that appropriately to the decision makers so that they understand the real world better, understand what I can do with these predictions, then possibly they can take better decisions back in the real world. Okay. So this is the goal and purpose of data science. Okay. Now, if you ask me the question that whether this pipeline always works, whether it's a magic wand, that whether, okay, as soon as I deploy data science, all problems will get solved, no. Right? The answer is definitely a no. It seems to be working for a lot of different situations and scenarios, but there are many failure points in this pipeline. Right? For example, you might not have relevant data for that particular problem, or the data that you have collected is of very bad quality. Right, which happens in, for example, when you're collecting data from sensors, right? The sensors could malfunction because of some temperature and pressure differences and all that, and you might not get data for a whole week. Right now, the data is not of good quality for you to really take it further for analysis. Right, that's a possibility. So there could be a data problem. There could be a techniques problem itself, which means you're not probably looking at the right technique for the problem, or the algorithms themselves could have certain limitations, right? Because of which you might not have selected the relevant technique, or you might not have come up with the right inferences and predictions, because the way it works is the algorithm will work on the data and optimize for a certain metric in order to come up with the predictions, right? So if you've chosen the wrong metric to optimize for, you might not get the right predictions. Again, if you don't understand this, don't worry. What I'm trying to say is, this pipeline, yes, it seems to be working for a lot of scenarios, but there are many failure points in this pipeline which we need to be wary of and overcome as we become practitioners in data science, right? And of course, once you have the inferences and predictions, you might have a communication problem. You might not have communicated the results appropriately to the decision makers, that they say, you know what, it doesn't make sense to me at all. And I have faced this situation many times also, where we develop a fantastic model, it has great predictions, it has great performance, etc. But then when we take it to a business decision maker, he or she might say, this doesn't seem to be very relevant for me, or whatever the false positives you're giving me is not good enough. I mean, I cannot, my situation is more kind of life and death kind of situations. And so I cannot really use your predictions to take decisions. I will go by my gut feel. There are situations that have happened, and that is a situation where probably it's not being communicated appropriately to the business decision makers, right? So given that there are many failure points in pipeline, but if you use it in the appropriate manner, and this is getting better and better all the time. The ability for us to extract all the data, store it, get large volumes of data, which is what we call as the big data paradigm, right? So if you can do that, and these mathematical techniques are also increasing in sophistication, and you exactly now know what techniques to use for what problems, and then you're coming up with inferences and predictions, which seems to be working for a whole lot of different scenarios. Right, and that is why there is a lot of interest in data science. Again, a quick look at problems. Data science is being used to solve a variety of problems. I'll point you to a few resources also down the line, but this is just a quick look at. So if you look at this slide, there are two types of problems, I would say, that are getting solved. One is which are core industry specific problems. So you look at the travel industry, the healthcare industry, the credit and the insurance space, right? So these are industry specific problems, which is very specific to an industry, which are deep, right? This disease prediction, medication effectiveness, etc., is probably not relevant for the travel industry, correct? So this is one type of problem. The other type of problem that gets solved with data science are problems which are more what we call as horizontal problems, like marketing. Cross-sell, upsell is relevant for almost all industries, right? How do you sell? For example, you have sold product A to a person, right? Product B is the premium version of that product, right? So how do you sell product B to the same person? That is upselling. Whereas cross-selling is I've sold product A and there is a different product that I have. One is a phone, the other one is a TV. Right? How can I cross-sell to a customer? And this is applicable across industries, right? If you really look at it. So there are problems around in marketing, in sales, in automation, right? Social media related data science issues and things like that. These are all applicable across different industries. And so there is once you have a pattern to it, then you can start applying it to different industries. Of course, you need to fine tune it. You need to make it relevant for that industry, but the pattern can be really used across industries, and there are many different problems that are getting solved or tried out across different industries. Okay. Now, I quickly wanted to touch upon this area of analytics, data science, AI, ML. I'm not going to go into detail, but just to give you a flavor of how all of these things are related, because we are talking about data science. Now, when I kind of take it out and then make it a little broader, I'm looking at analytics. Analytics is a tool to solve business problems by providing actionable insights to business stakeholders by using a combination of four things: business, data, math, and technology. Okay. Now I will relate this to a data science, but think of it that these are the four elements for any problem that you're going to solve using analytics. So analytics is a tool. It helps you to solve business problems. And how does it help you to do that? By creating actionable insights for the business stakeholders to say, oh, what price should I set? Which campaign should I run? What discount should I offer? How much product should I order? Right? Things like that. Using a combination of four things: business, data, math, and technology. Right? So quickly talking about these four aspects. So every single problem in analytics will involve these four components and nothing more. Right? You will have a business problem to solve. Okay, it could be a supply chain problem, a marketing problem, a finance issue, human resources problem, right? All kinds of different areas of business. Data is not just structured data alone, which is present in databases, but also unstructured data, which is your documents and images and videos, etc. And also sensor data, so what is called as semi-structured data, right? So these are all the different data elements that you could use. You deploy the math on top of it, right, which is what we saw earlier, and then all this has to be bundled together from a technology standpoint, right? Because think of a recommendation engine on an Amazon website or a Flipkart website. There is very sophisticated data science which is being done behind the scenes in order to come up with the recommendations, right? To tell you, okay, you have already bought these kinds of products. The next product that is recommended for you is this. There is a lot of analytics, data science that goes behind the scenes. But what makes it very useful for all of us? The way that it's getting delivered on a web interface, mobile interface, by which you can interact with it, do the transactions, provide the feedback, right? Think of a Swiggy, think of a Uber, think of Flipkart, Amazon, right? All these things, the power of the analytics or the power of this data science is kind of brought together. And so technology is acting like a glue that provides the real value to the end customer. So technology is becoming more and more important in the context of analytics, right? And so when we start defining some of these terms, I just want you to remember this. Again, the people use this interchangeably in the industry, but just to provide some clarity, when people talk about artificial intelligence and machine learning in this context of solving business problems, they are referring to the data and the math part of it. What data are you using? What type of data are you using? And what kind of a technique are you deploying on top of this data in order to come up with those insights and predictions, right? That is artificial intelligence and machine learning. When you include the business aspect of it, you call it data science. So why are you coming up with these predictions? And if I have these predictions, what business aspect can I change? Right? Going back to that problem of, if you're a bank, you have all the transactional information. If I know that somebody will leave the product or service, leave the bank in the next 1 month, I can take some action to prevent that from happening. Right? Exactly. Right. So that is the business aspect to that problem. And that is what is called as data science. Business, data, and math kind of coming together is what is called as data science. Analytics is a broad umbrella which includes the technology piece also, right? So when people say data science, typically, so I work for a company called LatentView Analytics. We are essentially a data science company, right? So which means that we focus primarily on the business data math part of it. We look at the data, we look at what business problem you're trying to solve, and that is what we have been doing. And of course, we work on machine learning, all these different types of algorithms. That is what we have been doing for a long time, and we continue to do it, right? But in the last 1.5 years, we have also built a lot of capability on the technology side, to the extent that out of the 750 people who are with the company right now, almost 100 to 150 people will belong to the technology space. It was zero 1.5 years back, right? 1.5 years back, these were the only two areas that we were concerned about. We were only looking at it as a data science kind of a company. But now we are bringing in a lot more of technology people, because every customer is now saying, okay, can we automate this process? Can we put it in production? Can we create an application around all the models that you have developed, right? So the technology is becoming more and more important. So right now, around 20% of the company that we have, of the people that we have, are focused on the technology area. Of course, 80% of the company is still these three areas of data science. And now we say we are an analytics company. We not only develop those insights, develop those predictions and insights, etc., but we also have the ability to deploy this at scale on the cloud and Google platforms, Azure, AWS, use Spark infrastructure, right? Many things are there from a technology standpoint in order to make it scalable, right? So now I'm working with 100 data points. Even tomorrow I get 1 million data points, my prediction still has got to work, right? And the model still has got to work. So that is the technology aspect of the whole thing, right? So analytics is the broad umbrella. Data science is a part of analytics which focuses on the business data math part of it. AI ML is being heavily utilized by data science in order to provide those insights and predictions, because that is where there is a combination of data and the mathematical techniques coming together in order to provide those insights and predictions. Okay. So hopefully this is clear. Okay, now let's, now that we have kind of understood a little bit on what is data science and also saw that relationship between data science, AI, machine learning, etc. Of course, talking about AI itself would take a fairly large amount of time, so I'm not going to delve into that in a lot of detail. But suffice to understand that data science leverages the power of artificial intelligence, because AI is this whole set of techniques, mathematical techniques, that helps me to solve different types of problems, right? For example, AI techniques or machine learning techniques are used to solve the perception problem. Perception is nothing but, if you have a document, if you have a video, if you have an image, right? Humans can easily understand, computers can't. How do you make computers understand an image? That is machine learning and deep learning and AI. Correct. So AI is one. There are techniques within that space which help me to solve the perception problem, and there is an inference problem, which is all your predictions and insights, etc., which is where machine learning plays a role. Then there is a decision-making problem, which is also a bunch of AI techniques are applicable there, and of course action, which is all robotics and things like that. So AI is a broad set of techniques, but then within the data science context, you utilize those techniques and bring it in the context of a specific business problem to solve, and that is, you're solving a data science problem. And then when we also build the technology pipelines in order to make this automated, run it in a repeatable manner, scale it on the cloud, etc., then you are basically talking about it as an analytical solution. Okay. With that, let me quickly move forward in terms of, I'm going to talk about a few trends. Again, probably I've spoken about all this earlier also, but just to reinforce this, trend one is that there is increasing use of data science across industries. Okay. Of course, it is used extensively in the technology space, and that is where everything started with the Googles and the Facebooks of the world, because they were collecting a whole lot of data, and they are very sophisticated in the use of data science, machine learning, and AI techniques, right? But across the board, in fact, the verticals that I manage, which is banking, financial services, insurance, then I also work on the consumer side, which is retail, consumer packaged goods, and hospitality. The last 3.5 years, there has been an increasing use of data science techniques for different types of problems, even within those industries. And even other areas like healthcare, automotive, energy, telecom. Again, these are all areas where there's a lot of use cases that are coming about. Right. So this is a chart from a McKinsey report. There are lots of reports which talks about which industry is using machine learning for what type of problems, etc. And if you're interested, you can take a look at this report. This is called the Age of Analytics report, which gives you by industry what are some of the data science use cases, machine learning use cases, and what problems are getting solved. Right. So this is an accelerating trend. Trend two is there are new and more sophisticated algorithms which are also coming up, especially in areas of deep learning. Again, I'm not going to get into a lot of details on this. I don't have the time. But these are some of the areas where there are definitely newer and newer algorithms that are coming up. But having said that, it's also becoming easier and easier to run these algorithms, right? Using AutoML kind of techniques, or you can actually use an Amazon API, right? For example, you don't have to create the algorithms yourself. You can use the algorithms or packages that are available as open source packages to solve your problems also. But having said that, for some of the complex areas, the image recognition is increasing, and that's a part of deep learning. That's increasing in stature. The whole this was a case study that I read recently of Rio Tinto, which is the world's, I think, one of the largest mining companies in the world. Their whole mine is all automated, right? Self-driving trucks and excavators to mine deeper and safer, because mining is a hazardous kind of a task. And so if you can make it autonomous, then you can do a lot more things, right? And save lives also. Similarly, if you look at this area called reinforcement learning, especially called something called deep reinforcement learning, that is an area which is focused on whether we can have computers take decisions also. Because if you really look at it, when I showed that picture of data science, the decision is actually taken by humans. You provide the insights and the predictions to the humans. The humans use those insights. They have their own thought process based on which they take a decision, because decision making is very complex, right? And to let a machine do it, we are only slowly approaching the space. One thing is whether it's really good to do that, I don't know, right? So that is something which is being looked at, whether we can actually have machines take decisions when there are humans involved, whether it will do it ethically, whether it will take all the moral things into consideration. So those are things which are also being researched, and it's a very fertile area of research. But techniques do exist, things around reinforcement learning and deep reinforcement learning, using which you can actually replace the humans with an AI agent which can automatically take decisions in whatever context. Okay, there is a possibility, but how it will pan out, what will happen, we'll only see over a period of time. Okay, the second trend is more new sophisticated algorithms, especially in the context of deep learning and areas of decision making, which is called as reinforcement learning. Then the trend three, which I spoke about earlier, is that the technology's role is expanding rapidly. And what I mean by technology here is that, think of it this way, right? So you have algorithms, you have data, but somebody has to acquire all that data, process all that data, right? Take it to the algorithm so that the algorithm can work on that data. And once a model gets created, somebody has to deploy the model somewhere so that for new data, the model could be utilized, right? So the whole pipeline has to be created, right? And you're talking about huge volumes of data. So you need to bring in all the technology aspects in order to build these pipelines so that it works in a seamless and an automated manner, right? So data pipelines and platforms increasing by this is a role that's greatly in demand right now. What is called as data engineering, right? Which is about engineering systems. And when I talk about data science and data engineering, the typical example I give is think of the Google search engine, right? So when you type in a search query, it gives you results, right? And the results are very precise in terms of based on the query that you ask for. And that's why Google has such a big market there, because the results given out by Google are considered much better than many of the other search engines when it comes to the relevance to the query asked, right? What happens behind the scenes is very sophisticated data science and machine learning techniques, right? Because it has to understand what the query is, it has to go back, look into all that data, and then get you the right kind of results, right? So there's very sophisticated analytics behind the scenes. But imagine a scenario where you put in a query and Google responds saying that, okay, I've got your query, come back after half an hour, right? I'll give you the results. Will we accept it? No, right? So you need that millisecond, sub-second, whatever, nanosecond kind of response that we need to have when you push in a query and then when you get the results. That is data engineering, right? Data engineering provides the ability for the data science piece of it to work and provide you precise results, but the customer gets it in that whatever sub-second kind of a response only because the system is engineered in the right way, right? So that the analytics behind the scenes is given to the consumer in a proper, appropriate manner and in a consumable manner, right? So keep that example in mind. I find that example very easy to kind of understand, so that when you start thinking about data science and data engineering and how does it, both are required in order to create that kind of value, right? Of course, the other technology areas I've just listed down here, things like DevOps, things like APIs, microservices, containerization, right? And the ability to embed these models, the machine learning models, into ERP and CRM software, full stack development, right? The front end development and things like that. All these are increasing in scale in the context of data science, because every customer now is saying, I think data science has value. I'm getting good insights, but I want it to be repeatable. I want it to be scalable. And so I need to engineer a system so that it gets done in an automated manner. And that is where there's a lot of technology that's kind of coming in, right? So when you hear things like big data, cloud, distributed processing, Hadoop, all these areas are related to the area of data engineering. Okay. So those are the three major trends. There are a few other trends which are more detailed, which I don't want to talk about it for an initial conversation. If I get an opportunity to deep dive on some of those areas, I can probably do it in a separate session. Things like explainability, right? One of the big problems in machine learning and AI is when you look at more sophisticated models, it becomes a black box. So you give data to it, it gives those predictions. But then if I have to explain a particular prediction, how this prediction was arrived at. So somebody applies for a loan, I push it through a machine learning model and it says deny the loan to this person, right? Now, how do you arrive at the conclusion that you'll have to deny the loan for this person is not something which is very clear when you're using a machine learning model, but it is required, right? So it is very much required in the case of regulated industries that you need to be able to explain what the predictions are all about. So that is the area called interpretability and things like called explainable AI. It's a very fertile area of research. I spoke about some of the other things also around decision making and things like that. So these are all areas within AI which are being looked at, and those are some of the important trends that are happening in that space. Quickly jumping on to opportunities as such, I'll quickly run through it. I'll probably take some questions also. So again, I'm putting it in the context of business, data, math, and technology. This is another easy way to understand this space. Every problem that you will work on in data science and analytics will only involve these four elements. What is the business aspect of it? What data are you using? Structured, unstructured, semi-structured? What kind of techniques are you going to deploy? And what technology platform are you going to use in order to create those pipelines, right? So business, data, math, and technology. Now, within this, opportunities exist for people across different areas. Again, if you can specialize in all four, great, but that takes a lot of time and need not. It's not necessary for anyone to specialize on all four. It's important to have an appreciation for all the four areas, but you can specialize in one or two of them. So if you're a business-focused person with functional knowledge, domain knowledge, etc., this is the role that you can look at, the opportunity to create the relevant use cases, interpret the analytics output in the context of the business, find out, because you have domain experience, you know insurance very well, you know what is the problem with the insurance industry at this point in time. You can also say, by using analytics, can I solve the problem? So that is what comes with domain expertise. If you are focusing on a data oriented role as a data analyst, as a data scientist, etc., you need to be well versed in these two areas. Especially if you're a data scientist, the math and quant comes in. But let's say you are a data oriented person as a data analyst, these are the things that you can work on. Ability to work with different types of data. As I said, if it's structured data, then you're going to have good solid expertise in SQL, right, in order to access all that data. And similarly, if it's some other type of data, you need to have expertise in data acquisition and data analysis, etc. Data visualization is extremely important. And the third one is, if you look at the real world data, there's going to be a lot of junk and noise. How do you subtract the noise and get the signals in order to work with the data, or the data oriented opportunities? The math and the quant, of course, the biggest thing is around data science. As a data scientist, selecting the appropriate techniques, the coding language and the platform, evaluating the output of the algorithms, etc. Right? These are some of the key skills or opportunities to develop your skills on from the math and the quant standpoint. From the tech and the software angle, is about creating the data pipelines, creating the applications, and also the whole software engineering area, right? Can I use DevOps? Can I use agile methodologies, right? Different methodologies by which I can bring all these four together in order to develop a product or deliver a project in data science, right? So broadly speaking, these are the different areas, and each one can, if you're approaching from a technology angle, then this is probably the space that you want to get in. If you're approaching from a data and a math and a algorithm standpoint as a data scientist, probably data and the math is the focus area. And then if you're approaching it from a business angle, then you can look at these areas by which you can add value to this space. Okay, it provides things for different kinds of people. And the good thing is you can also move from one to the other. I've seen people who have started out as a data scientist and over a period of time moved into data engineering. The other way around also, right? People come into data engineering and then move into data science if they are really interested. So a quick look at entry points for different experience levels. Again, this is just a simple example. So if you're a fresher or a junior developer, anywhere between 0 to 2 years of experience. If you have a functional background and MBA degree, you could be a business analyst. If you have an engineering science degree or a commerce degree, you could be a data analyst, right? Or if you have a technology experience in some big data, cloud, etc. With, let's say you have Java experience or AWS experience, Azure experience, you could come in as a big data or a cloud programmer. If you're a lead or an architect, anywhere between 5, 8 till 12 years of experience or 10 years of experience, you could be the functional or a domain lead, understanding the use cases, formulating the use cases, etc. You could be a senior data analyst who does all the data acquisition, processing, visualization, preparing the data. You could be a mid-level data scientist if you demonstrate good hands-on capability. Or again, from a technology side, you could be a data engineer, big data, or a cloud specialist. If you're a program manager, business head, or experienced person with, let's say 10, 12, 15, 18 years of experience, then these are some of the roles that I've seen people get into. A functional or a domain expert, an expert in a specific marketing, sales function, or an expert in banking, oil and gas, manufacturing kind of a domain. You could possibly get in as a mid-level data scientist, though this becomes a little difficult with more the number of years of experience. But yes, if you demonstrate enough hands-on capability, you could get in as a data scientist, analytics delivery manager, program manager, product managers. Again, these are some roles. Of course, as a consultant, because every organization is transforming digitally. And so you could be a digital transformation consultant, because analytics is a core part, or data science is a core part of any digital transformation. So you could be a consultant helping these organizations. My last slide is digital shift is a fundamental, irreversible change, right? And that is, all of us are experiencing that. And with the advent of COVID, it is accelerating even more, right? Things are becoming digital dramatically, right? And the moment you go digital, you're going to have lots and lots of data, as I showed in the first slide. Because one important aspect of going digital is to collect data, right? So it leads to a data deluge, or lots and lots of data, right? And that is unlocking new use cases across different areas of the business. And for the first time in the history of humanity, we also seem to have the technology power because of the open source revolution, the big data platforms, the open cloud capability that we have, because of which, even though some of the techniques are not new, regression is probably 200 years old, right? But you are now able to use many of them because of the technology power and the fact that you have use cases on which you can apply these mathematical techniques for specific business problems. I feel, and since that's a fundamental change, data science use cases will continue to accelerate into the future. We are only scratching the surface of what is possible now. We can solve a whole variety of problems and get into innovative methods and innovative ways of solving problems also, right? By using some of these areas. But it is not a magic wand. You need to use it responsibly. You need to understand how it works. You need to have the ability to make it work for your problem, right? And that is what everybody wants to learn on how to use data science. But the promise of data science is very interesting, and we can solve a whole variety of problems out there in the world. Right. So with that, I conclude my session. Thank you so much for your patient listening, patient hearing. I am ready to take any questions that you might have. Thank you once again.
Thank you, Mr. Karthikeyan, for your systematic presentation, explaining the concepts from the beginning about the data science and highlighting the trends, and also explaining about the opportunities based on the type of experience one has got. So it is a clearly excellent overview presentation, I would like to say. So we have a few questions, so I can ask them one by one, and possibly you can. Basically, when you started talking about data science, they're explaining about the machine learning and the statistics, the role of machine learning and statistics. Mm-hmm. So you are mentioning about the machine learning is used more for prediction, and the statistics being used for analysis. I mean, is it so? Or?
Okay. Yeah. So okay. Okay. So first thing is, I will refer to this paper by Leo Bremen called "The Tale of Two Cultures," which is probably the best paper on this subject in terms of what is the difference between statistics and machine learning. Right? Leo Bremen is a great statistician who is also a machine learning person. That's a starting. So the difference between statistics and machine learning in some sense is both relates to analysis. So the analysis part of it is, I would say it's common, but the goal of statistics is to really interpret the world and understand the world, right? For example, when I have a null hypothesis which says the mean of something, right, is 50, right? I'm trying to figure out whether the mean is actually 50 or not, right? That is what I'm focused on when I'm dealing with statistics. And I use samples and I use the extrapolation of the samples, all your p-values, etc., to figure out whether that is a real thing in the world, correct? Whereas the focus of machine learning is saying, you know what, I'm not too worried about understanding whether the mean is 50 or 75 in the world, but you give me enough historical data on X and Y, I should be able to create a mathematical function by which I can map X to Y, right? My goal is not to really understand what the data generating process is all about. I'm only worried about, can I create a mathematical function which can map from X to Y? That is the goal of machine learning, right?
Okay, when you are talking about the data, what is the importance of historical data, particularly when the technology is changing? Will the historical data will make it important, or will it skew the results of prediction?
Great question, right? So probably I didn't emphasize this earlier also. Without data, this field does not exist, right? So you need data is the raw material. Data is the starting point for anything that you do with artificial intelligence, machine learning, and things like that, right? Now the question is, the good news is that we seem to be getting a lot of data, right? There is a lot of data that is coming in. And in many cases, the data is also of good quality because many of the companies have put in ERP systems and CRM systems, etc. Because of it, there is reasonably good quality data about the transactions and things like that. So that is a good news. But on the other side, you cannot just take everything at face value. So you need to understand the type of data that is there. And there are statistical techniques based on which you can do that. right? You can use chi-square test or power equation models and things like that to really understand how good is the data, right? But it is also an art, because not everything can be done through statistics. You need to really say, okay, I am trying to solve this problem. I have this data. Let me experiment with it, right? And see whether I get good results, so that if I get good results, I can move forward and ensure that I can use this data for analysis. So historical data, especially labeled data, is very, very important to have. And it's also important to monitor the fact that if you've trained the model, for example, on specific data points, and you're using that model subsequently for new data points, the new data point should not be very different from the training data that was used to train the model. Correct? If it's very different, then you need to recalibrate the model again. And this is in the industry, it's called as model monitoring, right? Where you continuously keep monitoring the models that are developed to see whether the data skew has not happened to the underlying data that is coming in, or compared to the historical data that was used to train the model, right?
There is a question related to maturity of data science for a real-time analytics.
Okay, a real-time analytics kind of use case.
The case study is referring to a campaign, the marketing campaign, where there is some discounting, and then when to terminate, whether to increase or decrease the discount and things like that. So basically taking the inputs as the from the background and then running a real-time campaign. So what is the maturity of data science in this area?
Yeah. It's a interesting. So let me say this. I mean, the batch-oriented machine learning and analytics is probably the predominant way that problems are being solved right now, because the things that are required to do that activity, when you have batch data, when you have historical data nicely present in databases, is much easier to do as compared to streaming kind of data, right? But having said that, or more real-time type of use cases. But having said that, in certain scenarios, real-time use cases have a lot of value, right? Because the real-time implementation will help me to address the problems much faster. And so I would say it is increasing in maturity. And for real-time things to happen, the engineering aspect becomes extremely important. It's not the algorithm itself, but it is about things like, for example, if I'm doing it in a batch mode, right? I can run a deep learning neural network with 10 hidden layers. I have the compute capability probably to do it. But if I'm running my machine learning on a sensor, on an edge device, right, I can't obviously run a huge machine learning or a deep learning model. I need to optimize for it, right? So I need to have a way that I can actually run this much faster, and I can create nice, simple models for me to operate on the cloud itself, or sorry, on the edge itself. So it is gaining in maturity, and I think there are lots of use cases, but we need to think through that problem from an engineering standpoint, is what I would say. I think algorithms exist, and algorithms typically don't change. I can still use a logistic regression on an edge device, but then it is about the engineering based on which I can implement it in a real world use case or real time use case.
Okay. Can you provide some opportunities for startups in data science?
Oh, I mean, startups, this is probably I would say the most fertile area for startups in some sense, because you look at any single domain, right? There is an impact of data science. So you could really, if you just read about a particular domain, let's say you take a healthcare domain and you read about it and you talk to some healthcare specialist person, you'll be able to identify 5 different use cases almost very, very quickly, correct? Now the question is, identifying use case is one part of it, but for a startup, it is all about monetizing that use case, right? What will customers really pay for it when I develop a solution? Developing a solution is one part of the story, but then what customers will pay for that solution? Is it a pertinent issue right now? Is it a big enough problem right now? Those will come only with experience in that industry. So the way I see this is, if you approach it from a technology and a data science perspective, I think almost in all the different industries, there are data science use cases which can be formulated for all kinds of startups, right? Healthcare, financial services, manufacturing, etc. But I think we need to have a domain specialist who can actually provide you the fact that, okay, I know it's solving the problem, but by moving the accuracy from 70 to 75% probably will not make a big difference when it comes to that particular industry itself, right? Or it might in some cases. So that is where I think it's important to understand for a startup on whether that particular use case really makes a big impact in that industry, and whether people will pay the money to buy the product or service that you're creating, right? But bottom line is, I would say this is the best space to be in for freelancing, for startups, because you're on your own, right? You have open source technologies. I wouldn't have said that 5 years or 7 years back, when the only way to run a linear regression was only if you have access to SAS or SPSS, right?
SPSS, yeah.
Right? But now with the advent of many of these open source technologies, tools, and platforms, you can create the deepest of deep learning models sitting in the comfort of your home in 2 hours on your laptop, right? And that's what a startup person really needs, right? In terms of the ability to do some of this stuff and understand how certain things works. So I think this is a great area for startups.
Okay. What are the facilities available on cloud to develop data science solution? Like, without owning any software or any facility. So can you use the cloud facility to develop data science related applications?
Oh, absolutely. You can. The cloud is becoming very, very powerful in terms of creating some of these solutions itself. So if you listen to the chief data decision scientist at Google, a person by name Cassie, she has a lot of YouTube videos and all that. She talks about 2 things. She says creating AI is different from utilizing AI, right? Utilizing the power of AI. So you need not create AI solutions in order to utilize them, right? If you know what problem you're trying to solve, you could use the power of the cloud. For example, you can send an image to an Amazon API, and it will tell you what is exactly part of that image. It will do object detection, it will do emotion detection, it will tell you what kind of information is present on the image, video, etc., etc. So there is a lot of power in many of these cloud APIs for you to use some of those machine learning algorithms and models. And there are open source models also, right? Many of these big companies right now do the training, create the model, and actually open source it. The GPT-3, the BERT for NLP, etc. These are all open source models, and you can take it and just start using it, right? So definitely there is power in the cloud, but for every problem is in some sense unique in a certain way, right? So you need to be able to take it and adapt it for your problem which you're trying to solve, and that therein lies the trick. And I think the cloud will exponentially increase in terms of its capability, both on acquiring the data, storing it, processing it, the models, the algorithms that are available, right? And the ease with which you can create the models and things like that is definitely increasing on the cloud. Take AWS SageMaker, take the Azure ML platforms. These are all drag and drop platforms.
Okay. For a MS or postdoc student, can you suggest some research problems in data science?
Okay. I am not a researcher, but some of the things that I keep thinking about, which is very interesting, is this whole area of automated decision making, right? Which is what I call as the reinforcement learning, the deep reinforcement learning kind of areas, which I think there's already a good amount of research being done, but it's an evolving space. So I think there are possibilities there. The other interesting space I feel is the combination of simulations and machine learning and AI, because machine learning AI is data-driven decision making or data-driven models, right? Simulations are process-driven models, right? So is there a combination in terms of how you could solve problems much better by bringing both of them together? So I keep following this company called AnyLogic. AnyLogic is a simulations company, and they have a partnership with a company called Sky.ai. Sky.ai is a data science AI company. And if you go to AnyLogic website, you will see a series of conversations and panel discussions around how simulations and AI can come together in order to solve problems in a better manner, right? So that I think is a fertile area of research. In fact, recently I saw a course offered by MIT, an online course offered by MIT, which is about using simulations and AI in the context of engineering problems, right? Which involves the physics aspects of it also. I thought it was very interesting. Of course, the course was really highly priced, but the concept was there in terms of how do you kind of bring all of them together. That could be a research problem.
Okay. Can you briefly explain about data lakes and open data?
Okay. So data lake is a construct. It's a, you can think of it like a repository which holds data, right? It is in some sense a database, right? But what makes data lake different from database is that in a typical database, a data warehouse, operational data store, etc., which is what we typically call in the industry, the data is present in a, you will have to model the data, right? Which means you will have tables, you will have relationship between the tables. You need to create what is called as a schema. So in order to bring the data in, you need to first have a schema on which the data could actually sit and reside, right? So that's a typical database structure. Now, what happened in the industry was to say, you know what, it takes a long time to really get the data into the database because first I need to do the design. The design could be very complex, and then after I design it, the business could change, because of which I need to rework on the design of the database or the data model itself. And they said, is there an easier way to first bring in the data, and then depending on what I'm going to use the data for, can I impose a schema on it, right? And that is where data lakes came into prominence. Data lakes basically say that in order to get data into the data lake, you don't have to model the data, right? Just get it in. If you have some sensor data, just get it into the data lake. If you have sales data, just get it into the data lake. If you have customer data, just get it into the data lake, right? Then depending on the problem that you're trying to solve, you can impose a schema. Oh, for this problem, I need customer sales and order data. I can create a schema and start using it, right? So data lake is basically a paradigm where schema is on read or schema is on use, and it's not schema design at schema at design time, which was the scenario earlier when you're creating data. Right? So data lake is the problem of ingestion. You first ingest the data, but then that is where it's getting misused a lot because people think you don't have to model the data at all. You, in order to use the data, you'll have to model it at some time, at some point in time. Data lakes by itself will not solve the problem. But you can get in the data into the data lake, then use other ways by which you can model the data or organize the data differently, connect the data elements, and then do further analysis, further whatever, use it for machine learning models, use it for any type of analysis. So that's the difference between a data lake, or that's why data lake kind of fits in. Open data is different. Open data is essentially a way by which people have made data open, right? So if you go to open data, you will see whole different schemas that are there. You want to look at, I haven't visited open data for quite a while now, but now that you say it, probably I need to go back and kind of look at it. So it gives you domain-specific data that is all publicly available, right? And the beauty of open data is that since it's based on a linked schema paradigm, you can start linking different pieces of data to open data, so the open data kind of grows in scale and coverage, right? That's basically what is open data.
Okay. See, in fact, the data science, as we have been discussing, it is a multidisciplinary, both computer science and domain knowledge and statistics and mathematics and so on.
Yeah.
So, but in reality, who has got an edge to become a data scientist of all the three, or you need to have equal amount of knowledge?
So, okay. So I go back to this point about it is a combination, right? Business, data, math, and technology is the combination that you need in order to solve business problems, right? So as a team, if you look at it, you need all these four things. Somebody who thinks from a business perspective and the ability to interpret it from a business angle. You need people with data knowledge. You need people with the math and the stats knowledge. You need the technology folks, right? So this is the overall team that you need. Now, how much one person can have is something that can only, it depends on years of experience, right? So you could start off as being a data scientist and say, you know what, I'm going to focus on the data and the math part of it. Of course, I'm curious about business problem solving. I will understand a little bit of big data, cloud, etc. But essentially, my expertise is I know how to work with data. I know what algorithms I can use. I know what the statistical principles are, right? And I can create insights out of data. That is what a data scientist has to focus on. But not everybody needs to be a data scientist, because that's what I was saying. Using data science is different from creating data science. So what I will strongly encourage people to look at is, do you want to be a person who is creating data science solutions, or do you want to be a person who is utilizing data science solutions, right? If you are a person who is utilizing data science solutions, your focus is on technology, your focus is on business, right? And your focus is on how do you make use of some of these cloud platforms in order to get to the models, run the APIs, etc. But if you're a person creating data science solutions, then yes, you need to get focused a lot on the math and the stats behind it. What is good about a model? How do I adapt that model, right? Then where it gets confusing is many places I've seen people want to utilize data science and AI machine learning, but unfortunately they spend a lot of time learning back propagation, for example, right? That's not really required, right? Or any of those mathematical things behind a logistic regression, a logic function. You don't have to really understand in depth in order to start using data science for business problems. And appreciation will definitely help. And over a period of time, you can go deeper into it if you're really interested. Of course, it's fascinating, right? The back propagation is fascinating. The deep learning math is very interesting, but it's not necessary that everybody needs to learn that in order to be a data science professional. Does that make sense?
Yeah. So, can you briefly tell about data science application in cyber security?
Okay, I haven't really worked on cybersecurity areas, but I've seen use cases. The recent one I saw was on Kaggle, I think, where there was a machine learning problem which was posed there to detect malware, right? So there was a lot of these network logs that were there, and I think Microsoft had posed that problem on how do you use machine learning in order to detect malware in network logs. So, I'm not probably seeing the right thing here because I'm not though I'm fascinated by cybersecurity, I have no strong knowledge about it. But these are some of the, because I feel there'll be a lot of use cases in the cybersecurity space simply because of the fact that you have a lot of problems to solve, and it's a very data intensive domain also. There is just so much telemetry that is there in all these systems that it just generates a whole lot of data. So the moment you have the data and you have problems to solve, then it becomes a fertile area to kind of use data science for some of these techniques. So what I would request is, please look into that. I don't know whether the McKinsey report has a use case for cybersecurity, but look at the Kaggle problem. I think we'll get some ideas, or look at Kaggle, you might find some problems which are related to cybersecurity. And I think there are a few webinars also which are focused on that area.
Okay. Is there a solution for capturing clickstream data and log data of student engagement in online mode? Basically, the learning analytics, particularly in the context of online education becoming predominant.
Correct. So I don't know about a ready-made product that is there, but in fact, we have done quite a bit of work in that space also around, for example, we worked for, I forgot which university. This was basically about the students not completing the courses. They called it some term. I forgot what the term was. Based on the student behavior, and the behavior is captured in a lot of detail, right? Which videos they watch, whether they participate in forums and things like that. You can actually predict based on their activities whether a person will not complete the course, right? In a 6-month, 12-month period, and we used specific data science techniques to solve that problem. There was lots and lots of data, and that was truly big data in that sense, because they are tracking every single thing. A person scrolling on a video, right? How much of time a person watched the video, etc. All that gets captured now because it's all based on tags on those websites, and Google tags and all that capture all that information. Once you have that information, potentially you can use it for different use cases. So we have done it. I'm sure this is a classic use case, but whether there's a ready-made product to do it, I'm not aware of that.
Okay. So in the case of machine learning for data science, which is predominantly supervised learning or unsupervised learning?
I think both are used in the industry. Both are used extensively, but it's a little easier to use unsupervised machine learning because you don't need labels, right? So cases where you don't have labels, and unsupervised machine learning is a starting point in many cases, because, for example, let's say you have customer data, then a natural thing is to say, can I do customer segmentation? And customer segmentation requires clustering, which is an unsupervised machine learning technique, right? So it's little easier to use unsupervised machine learning. So if there is a problem to be solved and unsupervised learning can solve the problem, typically there'll be no hindrance to it, right? You can just get on with it. Whereas supervised learning requires labels. So either you have the labels already, in which case you can start off, there is no problem. And many of the business problems require supervised learning because you're predicting something, right? You're predicting a continuous variable in a regression kind of a scenario, or you're predicting a categorical variable in a classification kind of scenario. There are lots of use cases where this prediction is very important. There, if you don't have the label, then you might have to do that extra work. In fact, we have been in cases where we generate the labels based on the data, based on some business rules, we generate the labels, or we use Amazon Mechanical Turk kind of things where we ask them to label. In fact, there are companies that will label the data and give you. If you describe a scenario, we used a company called Fast 5. I think there are many companies like that, where you can tell them, you know what, here is my scenario, and can you get me sample data, right? Or labeled proper data. So they have a body of people whom they will work with in order to get you that labeled data. So then you can start working on supervised learning. So both are very, very much prevalent in the industry, but reinforcement learning, not as much, which is the automated decision-making part of it. I haven't seen any use cases. I mean, we've done pilots, proofs of concept, but a real-world implementation, at least I haven't seen that, and I think it'll be a very, very small part of the thing that is happening.
Nowadays, a lot of universities are offering courses on data science, BTech level.
Yeah.
I mean, you have any idea about the coverage of those courses, or whether a computer science course with some additional learning on statistics will be sufficient? Which one you prefer?
So the way I think about it is, again, I keep going back. Data science is a foundational skill. It is like teaching physics, chemistry, maths for the future. Data science, people have to be comfortable working with data. That's a given, and working with large volume and quantities of data, right? You take a research situation, you take a business situation, you take any societal problem that you can solve. I think data is going to be a very, very important raw material, right, in order to solve them. So the way it has to be taught, again, I don't have any strong notions on that, but the only thing I would say is not everybody needs to go in depth into the math and the stats part of it, right, in order to really utilize it, right? And that is so. I mean, what I'm trying to say is that we should not make people fear data science just because there is a lot of math and stats to it. And one of my pet peeves, if you can ask that way, is there is so much fantastic papers that are written in machine learning, but everything is written with a very strong academic focus, right? And the moment you see an integral, the moment you see a sigma, many people get put off.
Yeah, you won't even open the paper.
Exactly, you can't even open the paper, and we cannot afford to make that happen in the future. Where for our kids and everybody, they need to know that data science is a fascinating space and develop that curiosity. And that to me is far more. How you do it, I think there are some really wonderful professors and lecturers who are able to figure out how to teach that. But we need to make it really, really interesting in terms of saying you can solve real world problems. And this is one area where you can actually tell people, here is the real world problem, here is the data, can you solve it, right? So we need to make that as interesting as possible, in my opinion. And of course, there will always be people who are interested in the underlying math and stats part of it, because these are the people who will push the envelope, right? In order to come up with newer and newer algorithms, you need such people, absolutely, right? So I'm not belittling that at all. But that is a small proportion. A larger proportion should have the ability to look at this and say, okay, I know what data science is. I have an intuition towards what it does. I know what machine learning is. I can actually use it in the context of solving some of these problems. Oh, by the way, if I hit a roadblock, I will talk to a AI researcher and a machine learning researcher to really understand how it works, right? Make that, I think, really useful. Sorry, just one small thing. I remember, I think some of the things that came up in the educational space itself, right? So in my time, I studied around 1994 kind of a time frame. After, when I hear things like mechatronics and instrumentation and all that, I feel that colleges are moving in that direction. They're making it practical, taking a specific area and providing a lot of focus into an area. I think data science should be taught that way, right? And should be taught in the context of the business problem solving context.
Yeah, no. The question came up mainly because there are a lot of courses are being offered, even right from the BSc level. Like IIT, they have recently started online course on data science, BSc data science. So we are just wondering the relevance, or we are hyping the entire data science course. That is the basic.
That is inevitable, right? Because the moment you see a lot of demand, people will definitely create those courses. So that is kind of inevitable. But I think we need to tell our people that develop that curiosity. Basics are important, but more important is the curiosity. Say, can I really solve the problem? How will it solve? Why will it solve? Rather than saying, you know what, if you have the ability to, run this algorithm, you are considered great. That's really not the intent.
Okay. Okay. Thank you, Mr. Karthik, for the wonderful presentation. Now I request Dr. Saktivel, our chairman of IEEE Computer Society, to formally propose the vote of thanks. Dr. Saktivel, please.
Yes, sir. Good evening to all of you. On behalf of the Computer Society of India, Chennai chapter, IEEE Computer Society, Madras chapter, and the ACM Professional chapter, ACM Chennai Professional chapter, we would like to thank the resource person of today's webinar, Dr. Sankaran Karthikeyan, for his wonderful webinar wonderful talk on data science, trends and opportunities. The data science is an emerging field, and nowadays it creates a lot of employment opportunities. So he has given a wonderful overview of the data science, what is trends and opportunities in the area of data science. On behalf of all these associations, we would like to thank him wholeheartedly for his excellent presentation. Thank you very much, sir. I would like to thank Mr. H.R. Mohan, Chairman, ACM Chennai Professional Chapter, for his excellent arrangement of this webinar. I would also thank Mr. P.V. Subramaniam, Chairman, CSI Chennai Chapter, for his support in organizing this program. I would like to thank Dr. Akila, Managing MD member of CSI Chennai Chapter, for your support in organizing this webinar. I would like to thank all the participants who have participated through Google Meet link and YouTube link. So their participation is very much essential for running this kind of webinars. Large number of participants have participated through Google link and YouTube. So we wholeheartedly thank all the participants for their active participation in this webinar. So we would like to thank one and all for their active participation. Thank you very much. Thank you, one and all. Thank you.
Thank you, sir. Thank you very much. It's a real pleasure. Thank you.
Thank you. Before we formally close it, I just want to give some announcements regarding our forthcoming programs. We have one on 24th on the topic of cloud robotics, machine learning for cloud robotics. And then on 28th, we have a program on COVID-19, the role of medicinal plants and environmental hygiene. So both are relevant topics, and the invitations have already been circulated. So we request the members and other interested to please register and attend the program. So once again, my sincere thanks to Mr. Karthikeyan for the wonderful presentation, and all the participants for their excellent cooperation, and then providing a lot of questions to Mr. Karthikeyan to elaborate on the topic and presentation. Thank you very much.
Thank you. Thank you very much.
Good night to everyone.
Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.